Tony, remember when you asked me to do the analysis of Howard Johnson's work? You actually paid us here to do it. When Howard gave you the stuff down there.
Right, we went down to Blacksburg, and Brett and I and Pat went down and visited with Howard and Gladys, and Howard gave us this stuff, and then we drove it back, brought it to your lab, and yeah, we did. We asked you to perform an analysis. So I guess this is it, really.
Yes, this. So I'm here to give you the full report on what I think Howard was really up to, and give you the full analysis on this DVD. Well, I was working on magnetic fields, and I was going to explain how these magnetic fields work, and what I thought Howard Johnson was doing with his magnetic gates and things like that. So I was going to show some things here, and some tuning apparatuses to look at the magnetic fields that we built in 1984, which is over here, and a couple of little motors that have been seen all over that are gates, you know, that have these permanent magnets. And you can see that when I get the gate near the scalar tuner, you can see the beam being emitted through the gate. See? We use what we term a magnetic detector, which is a little device which tells the polarity of the magnet when you get close. And that says that's a south pole. And if we look at the gate, it says these are all north poles.
When did you build the gate?
Oh, I built the gate in, well, let's see here. I built so many different things that it's hard to remember. This was done in, and this was posted on KeelyNet on February 22nd, 1997 at 5:27 p.m. And so this is the gate that you're looking at right here. And so I kind of wanted to go through these magnetic fields with the people to show them how you can make an asymmetrical permanent magnet, which means then you can make a permanent magnet motor if you understand the principles.
So you've been working with magnetics for a long time.
For about 30 years. So I get started at a normal permanent magnet, in my opinion. And I'm not saying that all the scientists will agree with this, but we know a permanent magnet is having a north pole and a south pole. And the permanent magnet, when it's charged, when the grains are oriented in a certain direction, in other words, if they're oriented in this direction, then our fields are going to be the north pole up here and the south pole down here. And what's actually going to happen is when this is charged, we're going to have field lines that come out around the magnet like this. And so basically what's happening here, I'm just going to use a double line. I'm not going to go into the orientation or the mathematics behind it. I'm just going to explain it in simple terms so everybody can understand what they have to do. These magnetic streams that come out of this magnet are little bitty magnets, like Ed Leedscallion said in his post. And one of these vectors, or one of these magnetic lines, the direction that the magnetic streams are flowing is this arrow. So it's coming out of here and it's going this direction. All right? And the other one is running against that, like this. And the same thing's occurring on this side over here. So here's the thing. If we took these lines away, at this magnet, sorry for the eraser, but I couldn't find my eraser. If we looked at this magnet, we'd have an equator or something that's called a blotch wall. And depending on the size of this blotch wall is how powerful the magnet's going to be. So if this is really squished together in a really tiny line right here, then we're going to have a big magnetic field. So basically what happens is the energy comes in after it's charged and enters the blotch wall. And the little spirals here are the energy coming in. And so then when this stays, once it's charged and everything's oriented, it stays in a permanent magnet condition, and that means that it's a permanent magnet with the north and the south pole like this. So what can we do with this magnet? We can vary this blotch wall and change its position in the magnet by how we charge this magnet. Okay, and then the south pole is much stronger and the north pole is much weaker. So now we've just altered that magnet and we've made the field from this magnet sort of go like this. See? Which gives us a strong pole here and a weak pole here.
Just by moving the blotch wall up?
Just by moving the blotch wall off in how we can charge this and change the magnetic domains in the magnet, which are these little magnets that are going to line up. So if we move this up, we have a much weaker magnet on this side and a much stronger magnet on this side, because it's going to change the way the energy input comes into the magnet. And what we're looking at is a complex theory of 4 quadrants. And I always say when I'm doing something that that's delta 0 and delta 0 and delta 0 and delta 0. So these are fields that you really don't use unless you want to accomplish something in the magnet. So if you made this blotch wall where you could manipulate this blotch wall and make it from this direction to this direction, and you modulated this blotch wall with something, in other words, with a signal, let's say, what would happen is the magnetic field would ripple on the outside, just like this. So I've been putting all this together. And so I just wanted to start out with something basic. And we have a basic permanent magnet. And so, but we have to be able to understand how you can affect this permanent magnet. If you have something that's stationary, like this, with the blotch wall that's normal, right? You have even poles. So, suppose that we just had this normal magnet, and we wanted to take this normal magnet and we wanted to increase the strength on one side. Then what we do is very simple, is we would tip this with a piece of neo iron, and now this pole is stronger than this pole.
And what would your basic magnet be? If you're tipping it with
It would be right now what you're building is an asymmetrical magnet.
Right, but before you added anything, you had a magnet there.
Right.
What's that magnet made out of?
Oh, ferrite. This is a ferrite magnet, and what we're doing with the ferrite magnet is it's easy to tip with neo.
Okay.
So we're increasing this pole with a piece of neo. on here to add strength to the magnet on that side of the field. Okay?
Okay.
So if we wanted to add strength, say, to part of the magnet, we just tip it this much and leave the magnet like this. And so our fields now are going out further than they would be. Like this. So basically, when I say this, Tony, I'm building an asymmetrical magnet.
Right.
Or something that's nonlinear.
Right.
Because it's very important to be able to do this with a magnet if you want a magnet that's going to do a certain type of work for you. So the idea was, when looking at Howard Johnson's gates, studying what Howard Johnson was doing, when Howard Johnson did a magnet, he might have a piece of ferrite right here with the north here and a south here, and he wanted to direct that field, so he might have taken another magnet and he might have cut it at an angle like this, and this would have been a south and this would have been a north, all right? And then he might have tipped this down here with a piece of neo. So what he's actually doing is he's directing it this direction. And this side of the magnet stays pretty much normal, but sort of shields it a little bit.
So the first magnet would be like ferrite, and then what would be the triangular magnet would be what? Neo?
Well, no, the triangular, these are ferrite pieces.
Okay.
Okay, but the tip of it is neo.
Okay.
So we'll just call this neo, and this F, and this F.
Okay.
All right? So this is basically what Howard Johnson, how he was directing things around by making this. And so what happens is the field is going to go, going to sort of look like this. And so if I go over here and I get something and I look, let's say I just want to look at Howard Johnson's fields. You can see here that he's showing it. And then they've graphed out of when he makes these special magnets, that the magnetic field's light on this side and heavy on this side. And see, there's something else happening over here where the magnetic field is being sucked inward here, more or less, see it? And then he shows the magnetic lines down here of what's going on with these fields. So when you look at something that Howard Johnson did, you have to take into account that he's shaping the field that he wants. And there it is. And then this would be the contour of it, or what you would call a contour map. And this would be the magnetic lines of force as the computer plots all these points down in here. And so we can look at a few more first. And then you can see exactly what he was going to do here. If we look at it, here's some more magnetic maps. But you can see here we got completely some different shapes here. See, it's almost as if you could take this one and put it inside this one. See that?
Mirror image.
Yeah. And so if we look at his gates, when he did something, you can see here's a North Pole. And see, there's a piece of neo, and there's a cut magnetic block. And see, he says right here, notice the N, this is neo. That's a neo-south, because it's depicted as green.
And these are Howard's actual drawings.
Yes, these, and I'm going to show you a little bit more here. This can get very complicated, because when you build these gates, he knew exactly what he wanted to do and what the magnet blocks were going to look like. Of course, you know, Tony, Howard was a very secretive man, so he never really discussed any of this with just general people walking around out on the street. But,
or anybody.
Yeah, or anybody. And so when you understand how the magnetic gates work, you can do things like building trains. And let's look at something he was doing with a wheel. And you can see that nobody's even close to Howarda Johnsona. And this was done in 1996, because it says it right here. The twist motor using spin units. And you can see it right there for the armature. And you can see that nobody builds magnetic structures like that.
And clearly he had a method. I mean, this certainly wasn't random.
Yeah, so let's say we wanted to do something. See, if you look at what Howarda Johnsona did, let me get this out of the way and we'll get back up to the blackboard. If you notice, see, Howard is indicated here, neo ring on rear of front car. So he's talking about a car that's moving through this gate. And you can see here very closely that the gate is ceramic, and then he's got a different type material here, and then it's rubber, and then it's ceramic, and then it's neo, N-E-O, neo, rubber. See, so what's actually happening here is Howard is making up a magnet that's asymmetrical. And what Howard can do is, if this is the North Pole and this is the South Pole, we indicate it as a switch. So what Howard could do is switch this magnetic field completely around as another magnet passed it, and this would become a South Pole, and this would become a North Pole. So this is the switch in the magnet that we've always talked about, you being able to switch the magnetic field by bringing another magnet to it, close to it, like say another pole.
Is this flipping the spin?
Yes. In other words, if you were, Howard had this double spin theory, right?
Yeah.
And so what's going to happen here is when you bring this North Pole close to this pole, right? The way he's arranged the magnet by cutting all these different pieces is so these poles do a flip or a switch and then get fired out, because if it was south down here and you started to bring the magnet in,
right,
and this thing switched, you'd get an energy burst that looked like this in the magnetic field. And this is actually a potential between here and here. It's a potential of magnetic energy. Normally with a coil, we put a burst of energy in it, and it's electrical energy converted to magnetic energy. Yeah. But see, this already has everything that it needs to do it. So if you make this magnet right, and we're getting into a little bit of that, but the point being that now I've brought this north magnet very close to this south pole, but this is very weak, and all of a sudden this is what's going to happen. This is going to switch, and this is going to become a north, and this is going to become a south, and the rotor is going to go that way. The same as the train car. So if you look very closely, he's already depicted it here. He's got it laid out to run the car through. And you notice that he's against rubber here, and the end indicates neo. You can see it here. See? Right side, rotor, and here's his layout. A ceramic neo, double rubber, ceramic neo, double rubber, ceramic neo, double rubber. See? So he's causing the switch to happen in the motor. Okay, so let's move on to a few more of the drawings, and then we'll show you what could have possibly happened with what Howard was working on. If you look very closely here, you can see what Howard's doing. You see how he's got all the magnets together? See how he's making up the gates? You got a piece of neo, you got a piece of rubber, and you can see down in this picture right down here. This is a complex network of magnets, cut magnets, to make up a switching gate. So it's not quite as easy as everybody thinks to make what Howard was working on here.
No, well, I was in his lab, and
Yeah.
you could really see the complexity of what.
Right, but if you look here, look at the complexity
Yeah.
of all this. You see, so he's making up asymmetrical magnets to drive this car through the gate, which is a standard train that people could ride on once you pushed the lever and the magnets came in contact with the gate, then the train is pulled along the track all the way to the end.
Right.
And then all you have to do is reverse the other magnet, and it's going to go backwards. Now, a way to show you that with the spins is this little motor. Okay, these are cabinet latch magnets, and this is a piece of PVC pipe.
Okay.
And you get this many magnets to fit in, and you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's look at this gate.
No magic to the number.
No magic
Just
to the
whatever
number,
fits.
just whatever fits. No science behind this whatsoever.
Yeah.
Anybody can do this. And what that is, what that gate looks like is like this. Okay, so now we've got our magnets in there. And we know from the magnetic indicator, because you can see this again, it says north when it lights up there. And they're all north. Now, what did I just do by putting all these magnetic north? I told the vectors on the north poles to spin. I want everybody to pay very close attention to this drawing. It's not exactly, I'm not an artist, so I'm going to get it as close as I can. I've told all those vectors to spin into the center of the gate.
So that's a Fibonacci spiral.
Yes. Yes. And on the opposite side of the gate, I told them to reverse in the center at the blotch wall and go the opposite direction. So now, here's my gate. Right?
Right.
So if I say, okay, I'm facing the gate this direction, which is this direction. Here's the arrow. You got that?
Yep.
And I'm very careful, and I come down on the south pole. See, it wants to spin in the counterclockwise direction. See?
Yep.
Okay. Now I let it down, and I flip the arrow over. That means I've turned this gate around.
Right.
It has to go in the other direction, which is clockwise.
Which is what the Faraday motor does when you flip the...
Yes. But this is a magnetic spin.
Right.
See, without any energy. There's no
Right.
electricity here to do that.
Right.
All right? So I can measure this gate by just taking this gate and looking at the beam. And so we can look at the gate in terms of a scalar. So when I come up, see as the magnetic materials move around, I'm just focusing the gate on it.
So this scalar detector detects any
Right.
time there's a scalar.
Right, now look at how far this is going out. See, I'm moving it. See? So now if I want to look at the south pole,
Back up a little bit. The gate, what exactly is that showing us when you
it's showing me the scalar. This is a scalar
Right.
being emitted.
and you're showing that it's
It's a
quite
beam.
You're showing it's quite far away.
It's quite focused. See it?
Right, right.
And I can flip it around and you can watch the needle jump. See?
Right.
Right. And I can show you that what's coming out of here is just magnetism, because it's not focused.
Right.
It's just a big magnetic field. So let's say I have all these magnets sitting up here. They're all opposing north poles on this magnetic motor.
Right.
Right, and I just give this magnetic motor a spin. Look at the tuner, because it's detecting the scalars. So I can actually map this field if I wanted to put this into a computer. And watch. See, it's still oscillating.
Yeah, the magnitude is sort of independent of the RPM.
Yeah.
Yeah.
And so if we go and we want to look, say we want to turn the gain down, right? Because we want to gain with this. This is a zero-sum field. This is where both signals come and are summed together to cancel out and cause a zero.
Right.
So anything that is asymmetrical to this is going to produce a wave.
Right.
If there's a differential between this one and this one. So it's a differential indicator. So if I take a wheel in space and I spin a wheel in space, here, let's back up because the fields are powerful. You can see that what you're looking at is there's a magnet out here and there's a magnet here, and you're looking at the RPM of this wheel, right, as it goes through space and causes a differential. So if I stop the wheel, it goes down. If I move the wheel faster, it generates more spatial field. And so therefore, you're going to get a higher output. And the tuner's indicating that. So if I back the tuner down, because it is a big field, you can see the needle bouncing as this rotates. And this is what it is, because it's a north and south field. Look. And that's what it's indicating right there, because if I stop the wheel, there's nothing there. Now if I go the other direction, it's going to indicate it again. Because remember, it's a continuous north and south.
And that's the Bedini cold window motor.
Yes. And any one of the motors, if I took, we're just talking about magnets. Any one of the motors, if I took any one of the motors, and anything, by the way, anything that I do in the area that has to do with magnetism is going to be detected, because that's the way I've set it up, is to be a detector.
You set the scalar
Yes, I've set the scalar tuner up now.
to detect
Yeah,
magnetic.
and you can see here, look, all I have to do is just touch. See, look, I'm not moving very much.
Hold on.
See how big that is? That means if I spin this wheel, I have to turn the gain down because the magnetic field is so great. In fact, it's beyond what the scope of the tuner is actually designed for, so we have to go backwards and then detect. So see, I want to see how it's affecting space. See? So that means it's out here. See, watch. And if I go faster, the spatial field gets warped into a bigger dimension. See, look. I mean, you got all these magnets now. And this is a spatial disturbance. See? Every time I do something, look. And if I tap on the floor, you're disturbing space. You're disturbing the magnetic field lines in space. So anyway, we've seen basically that we can measure these things if we build devices that are different to capture the differentials. But the whole thing is Howard here. And why is Howard doing what he's doing here? You can see that he's creating the exact field that he wants here. Let me see if I can get some better pictures. Here's a train going through a gate. See, Howard always puts red and green. So that means that this south here, and you can see, is going to go into that south. And see, look, he's got a tension scale on it. So he can tell you what the power is.
Yeah.
As it goes through to the gate. Again, it says right here, 13 gates, 1 short, 12 normal, spare 1/2. See? And he tells you, July 26, 1994, he experimented with it.
Yeah.
Of this type gate. And here's experiment 46, July 25th, 1994. And every one of these is marked as an experiment to understand what these nonlinear asymmetrical magnets are going to do. And so when you put something through the gate, right, you see it's attracted in here. Watch. See? But it wants to be, I can't quite hold it because it's powerful when it wants to go through there.
Right.
But when it pushes through that gate, it's expelled.
Right.
See?
Right.
That's the switch right there.
Right.
So if I turn it around,
So you made a gate with just simple.
see, look at how it's sucked it in.
Yeah.
Watch. Kind of neat, huh?
Yeah. And the ball bearing's nothing special.
Nothing. It's a piece of iron. In fact, it helps being sucked in.
Right.
In this direction. It's attracted and then switched. Here it is.
Yeah.
See? And I can just take it. See? If I hold it straight. But the gate actually wants to attract in.
Whoa.
See it go through there?
Yeah.
And so we can look at the spins by just watching what the gate's doing. See, if we turn over, it's go in the other direction.
And just to
And it really wants to go.
yeah, oh wow.
Yeah, so,
And just to reiterate, this
that's just lines.
these are just lines,
Yes.
and this is just a regular magnet. This is not a
Yeah,
whole.
well-
these are not segments of a magnet. This is
Oh,
just
no, this is a
Yeah.
regular magnet, because I'll do this in front of you.
yeah. No,
And,
just for so people understand.
Yeah, well, I want people to understand that normal magnets, here it is. You see, I know this is the north gate, so I know I have to pick it up,
Right.
And so I know I need a south. That's a north, which means it's repelling that
Right.
gate, and actually is going to suck through, see?
Right.
So I need a south. So I need to put this on the north side. And that's the same magnet that's right there. And I need to just put that ball there. And it's going to do identically the same thing.
Yep. Yep.
So I can see what direction, how this gate that I built in 97 actually works. And it's a vortex. It's coming, it's sucking this direction and outputting that direction.
Is this in the magnetics textbooks?
No. No. The next thing that's not in the magnetic textbook is this. North Pole, South Pole. Right? North Pole, South Pole.
Right.
Well, everybody's been taught that those poles repel each other. So what you do is you do exactly like I showed in 97, pushing the two north poles together. And the south pole becomes weak then on each side, and the output doubles on the north side. So I'm going to just blow it up a little bit. I have a north pole here, and a north pole here, south pole here, south pole there. So assuming these are both the same size, which I did not draw the same size, we're gonna call them equal.
Okay.
These two magnets become equal, all right?
Mm-hmm.
So, yeah, I'm going to show you something. I'm going to show everybody this. One time. I'm going to show you the poles. Here's the north pole. So I'm going to mark it north. So we know the other one's the south pole. What can this magnet pick up? Can it pick up this ball? No. But when I force the next north pole to this one, change it 90 degrees, how much more power is there?
Can you turn it towards the camera more? It's like a sandwich. Yeah. Okay.
Yeah. See, but alone, the South Pole now has no power.
Yeah.
Because what I told this magnet to do, well, it's fun to play with magnets, Tony, because no matter what you do, they're all over the place. What I told this magnet to do was this: squish these out in a beam like this. And this to become weak. So now my fields start to look like this. And the same for this side. That's why I developed the monopole engine, because if I have a north here, and a north here, and a north here, and a north here, right? Then I'm telling it to do this. I'm telling it to do this kind of field. Because these are souths, right? Mm-hmm. And so these are going to go directly to the shaft, like this.
Isn't that the diagram you've got on your website?
Yes, that's the monopole engine.
Okay.
Okay, so if I want to change the spike, in other words, if I wanted to take the monopole, which uses a coil here to trigger, what I would do is if I didn't like the normal wide beam, right? Because if you look very closely to what I just did, I've narrowed the beam. See, look, watch.
Yeah. Right.
I've told it to narrow that beam and double in power. So therefore, when I come across this coil, I come across this coil with this really sharp beam. Well, if I have this real sharp beam that just goes across the coil, I can't burn very much energy.
Right.
But I have 4 times the strength to push the monopole.
Yeah.
And it's all done through canceling out 2 poles, the 2 south poles. So, back to Howard. I think what, I want to show you some more things with Howard before I actually show a demonstration of how his gates actually look, because nobody's ever really been able to run a magnetic detector, Tony, across his gates. And we're going to do that.
Okay.
You can see they're testing this gate right here. And see, look, this is a rotary gate. See, it's got to go through a window. Notice that? Isn't this a window here? See?
Oh.
This is going through a window.
Where's the window on the Bedini cold window?
Right here, this is the window. See, you're
Oh, okay.
going through this window,
Yeah.
right? In other
So
words,
we got a window going on here.
yeah, you got a window going on with this motor. And you can see he's building the gates for that motor down here.
Where's he building the gates?
Right here,
Right there. Yeah.
see?
Yeah.
And there is how he's already figured out the magnetic fields.
Yeah.
All right, so basically, this is pretty hard for somebody to do, isn't it?
Yeah.
If you don't understand what's going on. We have to look at what Howarda Johnsona was really doing here. See? With the gates. See?
Yeah.
Notice the difference? See, they're offset.
Yeah.
Okay, this is what would be termed as sort of a V-gate engine that Howard was working on. Whether he completed that or not is not known. But let's look at some of the fields that he looked at. I mean, who would make magnets that look like this unless you were trying to build some kind of engine device?
Yeah.
Okay. So how do we do it, right? If you look at all these magnetic fields that Howard had analyzed here by computer, each one of these has a specific field, the north and south side. See this one spiraling around?
Yeah.
There's a completely different gate. Each one of these is a gate, and take a look at this one. Sort of looks like a top.
Looks like a jellyfish.
Yeah, with south field emanating lines there, see?
Looks like a Walter Russell
Right.
drawing.
Yes, exactly. So, and look at this one down here. I mean, if Howard Johnson knew his magnetic structures and he knew how to do it. And so let's continue on here. Let's look at what Howard was really making here.
Our most tested design.
Yes. Now here's a packed stator neo armature motor. See it? And notice the gate, it's going through a window, like the window motor right here. See how these magnets go through the window? Just this little bitty window.
Yeah.
Well, this one takes energy, but this one doesn't take any energy. And here it is. And then notice Howard here. I think this is Howard.
That's Howard, yeah.
And notice he's working on the plastic rotor to go through the gates. So he's definitely planning right here to build a rotary motor. And so if we look at this, notice this wheel. And then we look at this wheel, see he's already got it cut out for the gates. And he actually had this all put together like this. It's
kind of
we're gonna restore it.
Yeah.
For Howard, but notice the layout here as this goes around. See, these are all making V's. See them? And they're offset. Notice that? Mm-hmm. And so this type motor, if it actually ran, which I do believe that Howard would have got this to run, would actually have went until it got up to its rotational speed for the magnets.
Yeah.
And so, what are we talking about? We're talking about Howard's non-symmetrical, asymmetrical magnets. And the way Howard Johnson did this is if he had a magnet, and this was the North Pole and this was the South Pole, he would do something to make this magnetic field that normally looks like this with iron filings. And I'm going to keep this on a very simple wavelength for everybody so they understand. In other words, if you go back and you understand what's going on in the permanent magnet, you know that the permanent magnet, people have talked about the blotch wall. That's the center of this magnet. I get so many questions. John, what are you talking about? This is the blotch wall.
Yeah, you've covered that in about 3 DVDs now.
Okay.
Yeah.
So I want everybody to understand.
I just have a quick question
Yeah.
on the blotch wall. Is that in the textbooks as well?
Yes.
Yeah.
Yes. But it's not explained. It's the absence
Right.
of all magnetism.
Right.
See? Now some say that this one little arrow, we'll just call it a vector. We'll call it a magnetic stream. Let's call it a magnetic stream because that's what it is. But there's something very interesting here. The field that's being generated by this magnet is not really part of this magnet. It's part of space.
Right.
And so some people say, well, that doesn't do that. That goes like this.
It's impressing this field in space.
Right.
Yeah.
And it switches over here in the center of the blotch wall. Well, if these are all equal, and we take all this out, and I'm just going to redraw this. We'll keep the blotch wall there because we want to keep that right in front of you. The reason that it doesn't go in here, Tony, is because it doesn't have to. It's because Ed Leedscallion was absolutely right when he said this magnetic stream is spinning this direction and that magnetic stream is spinning that direction.
That was the guy in Florida that built
The Coral Castle.
the Coral Castle.
Right. And so these are neutraled out. This is just a device. This magnet now that I'm holding in my hand, right, is just a static device. It's not doing anything out there in space, except emanating its magnetic streams, which you cannot see.
Right.
But you can see them when I come close to this tuner, see it?
Yeah.
See as I turn it? Because I'm making space do this.
Right.
You see, I'm modulating space with this right now. See? And when I do that, when I flip that magnetic field, I'm actually modulating space. I'm going from north to south to north to south. And I can put this wave out in space, but it's invisible. Nobody can see this wave. But the real thing here about Howarda Johnson is Howarda Johnson wanted this magnet to be switchable. In other words, if somebody put a little switch in here that took this North Pole and put it this way, and this South Pole and put it this way with a trigger. In other words, I'm going to throw this switch, which is not an electrical switch. It has to do with magnetism, the unseen force. And I come by and I do something with this magnet out here, right? And as I get close to what Howard was building here, these things can switch. Well, you can't have a permanent magnet motor unless something is switched. You have to have an imbalance in the permanent magnet motor with the rotor. So you have a coil on this side and you have a coil on this side, right?
Right.
And then when this thing turns around and gets the electricity, it repels this one. So that means there's an imbalance now and attracts the other one.
Right.
So there has to be an imbalance somewhere for that to work. So the point being that I can make a magnetic field do anything I want because a magnetic field is a complex device that I know all these streams are emanating from the magnetic field. Now, we know that this is a static magnet. It's just sitting here like this, right? And we take that magnet and we say, gee, how can we make this magnet so the North Pole is not so strong, but the South Pole's real strong. So I want to come in on this side, and I want the magnet to make a switch, and then I want it to push out the other side. Well, there's one way to do that. We can align these magnets into what I call a gate. So we would be looking at this gate. And all these poles would be the same here. Now I come through the gate. I put a little piece of steel ball here to make the magnet non-linear. I want to suck the field lines to that ball so that this looks like a south, see, to the north. And this is what you get.
So you're tricking the gate.
Yes, and then when I get to a certain point, then it's pushed, see?
Yeah.
So I want to switch this. This is an example. There's a lot of work to be done with this to make it do so that it doesn't fight going through the gate, right? But if you look at it, all these things are pushing. See? And the South Pole's out here, right? Being that they're south, their magnetic field wants to go like this, which it can't do, because it has to come in and then be pushed this way like this. See, and it can't do it here. So a little bit gets around here, and the rest gets pushed out in a scalar out like this. See? So if we map all these magnetic fields, that's what we're going to see. We're going to see what Howarda's depicting right here. Something, say, like this. Or something like this.
These are all the plots that he did at university.
Yes, these are the plot universities. Okay, so what this allows us to do then is to build reality the way we want it by just doing this. I have this magnet and say, I want this north to be more pronounced on this side. Then I would take Howard's method and I'd put a little small neomagnet right over here, right? That had a south pole here.
Yeah.
And then what this magnetic field would do would make a lobe like this. See, you can't go that way. See, it's repelled here. So what it wants to do is it wants to squirt out like this. But this way, it wants to do this. You see what's happening here? So maybe Howard might want to trick this end. This staying the same. And putting a piece of neo here. See?
Yeah.
That's a North Pole. Which he's done in all his gates. And then this is going to make the lobe come this direction. See, and I'm going to end up with something that looks like this.
Yeah.
See? You might want it to look like that. Now that's a map that you would think would be something that the Geological Society would put out. See?
Yeah, it looks like a topographic.
Topological map, right?
Yeah.
And so, but see what's happening with these fields as he adds his magnets? Look at
Yeah.
this. See? This is telling us that Howard was going to build a motor. See, look at this magnet here. Dual banana attract. Dual banana attract. Run. Dual banana repel. Dual banana repel. Dual banana repel. Now, if you noticed in all Howard's banana magnets, he could change the influence of the magnet.
Who made these? He didn't make these banana magnets. Did he? You could buy a
You
banana.
could get banana magnets, and they were used probably for motor magnets, you know, around an armature.
Right. Can you still get them?
Yes. Anyway, banana magnet, you know, he had them so they were sort of like this, because if I remember right, you said he couldn't wait to get his little rock saw out to cut the magnetic blocks for what he was going to do.
Right. He was waiting for the weather to where he could
Yes.
change to where he could get outside and start doing that stuff.
Well, if you notice, some of Howard's banana magnets right here, he's tipped with a piece of neo.
Right.
And he always indicates that with N.
Right.
And then he puts the dot here, what polarity it is.
Right.
So if this is a south or a north, then you know this is a south and this is a north.
Right.
You know, this end. But this end is far stronger than that end. And that's what's depicted with what he's doing with the banana magnets here.
Yeah.
See? Asymmetrical magnet.
These are all dual banana repel.
Yeah, yeah.
Dual banana repel.
Right.
Dual banana repel. Dual banana attract. Dual banana attract. Dual banana attract.
Right. So he's
Dual
changed.
banana attract.
Right, but notice what he's done. If you look at his magnets here really close, you'll see he's tipped these differently.
Right.
See them?
Yeah, let me get in close here. Yeah, you can see it.
Mm-hmm.
Yeah.
Well, that's going to do something funny, because if this is the North Pole, right?
Mm-hmm.
And this is the South Pole, this is weak and this is strong.
Yeah.
So it's going to make the field uneven.
Yeah.
It's going to make the field very uneven across here.
Yeah.
See? And of course, what's going to happen here is the blotch wall is going to change position.
Yeah.
You see? Instead of being in the center where
Yeah.
it belongs, it's going to change position. Which means what he wants to have happen here is he wants this thing to move in a switch zone
Yeah.
as it goes through,
Yeah.
so that it can go through the gate, can sail through with ease. It's like adding a little piece of steel here to go into this gate.
Right.
You know, putting that little piece of steel like that to go into the gate. And see, it's actually floating if you look at it. If you get down below the camera, look here. See, I'm pushing.
Right. And you.
It's actually hovering. See, if I turn the gate around,
Yeah.
it's sucking out of the table.
Okay. Go back to the other way then.
Yeah.
So basically, it's just hovering there.
Yeah, well,
But you have to support it.
I have to support it because it wants to flip to the side because of the spin.
Right.
But it's hovering there. See?
Right.
You can see that. And if I turn the gate the other way, that means the spin's going to go the other direction, right?
Mm-hmm.
See? And it's going to suck through.
Yeah.
See? I can put it down.
Yeah. And just to reiterate, the ball bearing is just there just to distort the field of the small magnet.
Yes, that's all it is. In other words, what I really want to look at, and it's hard to draw because what I want to look at is something that sort of looks like this. So I'm trying to do something because I've distorted these lines with the iron.
Sort of like the bow of a ship.
Yes. And so, you know, when we come to the conclusion, you know, what did Floyd Sweet do, right? Floyd Sweet actually changed the magnets. Floyd Sweet's machine looked like it was an attraction. Not an artist. Okay? It looked like it was an attraction north, south, right?
Right.
But when we analyze it, Floyd Sweet heated these magnets and then recharged the magnet with the signal that he wanted so that he could orient the signal in the magnets. So that when the oscillator came into the magnets, he was making a very, very, very nonlinear magnet because Floyd said he was getting to the nucleus of the magnet, which very well may be.
Yeah.
You know, but he had a cross-wound coil.
Right.
Right? And by putting the signal in at the blotch wall down the center.
Right.
See? Remember I said in the beginning somewhere in the film that there's this blotch wall that's running around the magnet. But I said there were 4 quadrants.
Right.
So that there's one that's running this way too. See? That's in between. This might be an easier way to say it.
Right.
That's in between these lines that are in motion. There's a blotch wall, or I call it a delta zero here. There's one here. And there's one across the magnet. So if I come in, and I'm really clever, and I figure out the exact point of this blotch wall, I can modulate it. If I modulate it, and my magnets have been conditioned to be asymmetrical, right?
Yeah.
Then what's going to happen here? This was a north pole and this is a south pole. They're going to start switching back and forth. Well, what's 90 degrees from that? The power coil. Right?
Yeah.
Well, it's going to make a dipole. One set of spins are going to go down the wire this way, emanating from it, and the other is going to go down the opposite end, and you're going to get AC. You're going to get this. You're going to get this wave out of it.
Yeah.
Unless you rectify it. And so you're making this structure, you're programming this structure the same way Howarda Johnsona is programming his gates.
Yeah.
And they're stationary.
Yeah.
Okay. So,
Yeah, I bet most people never even thought that there was any sort of similarity between what Floyd Sweet was doing.
oh no, there's a lot of similarity. People just term it completely different.
Yeah.
And the point is to be able to measure, to understand that if you're going to make a magnetic structure and you're going to cut the pieces with a rock saw, and you're going to go this direction, and then you're going to tip this one, right?
Yeah.
And say you tip it over here.
right?
Yeah.
You know what's going to happen to the field.
Yeah.
You just know that when you start to measure things out, it's going to look, it takes thousands of data points to get the field out of this.
Yeah.
And this may be in repulsion, you don't know, and it may want to go like this out of here somewhere. See?
Yeah.
And you're going to get this strange looking magnetic field that's going to give you something that's going to look,
You're going to get something that looks like that.
Yeah.
right? And Howard made so many of these strange magnetic structures that once again I have to go back here and show you. I'm going to leave it down here because it might be better.
Well, hold up a little bit because I can't get in. That's good.
Oops.
That's good.
That you're going to get these type fields. I mean, look at this one.
Yeah.
So now let's look at Howard's train. So this is a train, and I want everybody to notice that look at the way these gates are made. Here.
This is Howard Johnson's original gate.
Yes, this is original
Or
gate.
his latest. This is
Right.
the one that he was really proud of.
Right, because look here, this is Neo. Look at this. Look here along.
So what do you actually...
I'm showing you that it's alternating all along here.
Let me come around the side then. Oh, while you're doing that.
And let's go on the inside. And if we go along the top, so you notice that Howard's gate on the train, he's made up these gates with alternating magnets. You can look, maybe you can get a real good close-up shot of all these gates. And he says that this one, see Howard puts dots. He puts dots in the direction of the fields. See them?
Right.
North, south, north, south, north, south, north, south. See here? And if you look down the side here, when we laboratory tested this, you can see the magnetic fields in Gauss. 13.05, 14.1, 15, see, 16.2, 17, 18, 17, 20. It's pulling this way, right? See, and it keeps climbing.
Yeah.
And notice what he says here, that the car's magnet is shaped south-north. So that means that when you look at these magnets, see, he's made this curved magnet up. Look at it. And you know why it's alternating? Because Howard has the two-particle spin theory.
Okay.
And so by spinning in one direction with a hard field and then spinning the opposite direction with a soft field, he can pull this car through here. Like that, with acceleration, because it's spinning. He can pull this car through here because it's spinning.
Right.
See? And if we reverse the direction of the car,
Yeah, try not to hit your cameraman in the,
see, you gotta orient it the right direction,
right,
or it's just gonna come flying out of that gate, see?
right,
Because that's a gate right there. See it?
yeah,
It's doing the switching right now. Right here.
yeah,
See how the field's nulled out? I'm not getting a field.
huh,
See, it's zero in here. There. Right there, I'm getting it. See? And there it just switched.
right.
See?
I can't get a shot of the,
See? That's the field that's affecting it.
oh,
See? Now watch. If I turn the car around, if I can get the wheels on it, it's going to go that direction, see?
right,
And it can sit in the neutral zone,
right,
see? Look, I can't force it, see? There's a null. Null. So what's happening is the gate's nulling out until it gets to the end.
right,
Watch here.
yeah,
See? And Howard's made up all these magnets. So he just made up the banana magnet that he wanted. And he's done this. If you look very closely, look, here's a piece of rubber magnet. See, look, neo, ferrite, rubber, neo, ferrite, rubber. See here?
right. Yeah, and in actuality, in the first DVD that we did with Howarda Johnsona, there's a schematic of the way the magnets are laid out, which shows this.
Right.
So it's worth studying it.
Now here, if you'll come around this side, here's the other thing. He curved the field underneath here, see it?
Right, I always wondered what that was.
Well, look at this. See, it's a north end this way.
Yeah. And he used to keep a piece of wood over there so you couldn't see
Yeah,
it.
right, because that's a banana magnet underneath there.
Yeah, but it
If
was
you
kind of a
look-
secret that
Yeah.
he had it under there.
Right.
Yeah.
Well, there are no more secrets because we're explaining to you what he did.
Yeah.
You know, now I want everybody to understand that I'm keeping this on a very simple level because not everybody's technical. But what's actually happening here with when you arrange a magnet like this, and then you just off the wall decide to put a magnet here like that, which he's cut all these different shapes, right? That when you run these magnetic fields, this may be a north here, and this may be a south, and this may be a north, and this may be a south, and this may be the blotch wall of a magnet that he's cut. You follow me?
Yeah.
With a piece of rubber in between.
Right.
And they're all glued together. So when you run a magnetic indicator or a Gauss meter over this XY plot, you're going to get a dot, and 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 you're going to get a dot. And these are all measurements. All right? And you're going to get dots, you know, in Gauss. And that's what you see right along here with these numbers, because we've already measured this for you. And you can see what the magnetic strength is as the car comes through the track.
Let me go through it first. Yeah, it certainly takes a lot of the mystery out of it.
Yes. And so by getting these dot points, then we can go ahead, and this takes a lot of work, folks, it takes a lot of work to do this because you just, you got to take your time and you're going to measure this stuff out. And you're going to have all these points out here. So you're going to end up by, when you connect the points, right? You have the computer connect the points, it's going to start generating fields. See? It's going to start generating these fields. Because there are going to be all these points in here.
Right.
And this takes hours and hours and hours to figure out exactly what this field looks like. And what Howard has here is a complex gate, which does one thing. It's going to change polarity when the magnet goes by it. It's going to want to switch these polarities. And so if you looked at this, if you look at it in real simplistic forms, it spins. It spins. It spins that direction, right?
Yeah.
And the other side spins the opposite direction, which drives the car through the gate. So everybody, I hope everybody learned something from what was just explained here, but here is what it leads up to. Knowing what the gate does, it leads up to a disc. It looks as if you're looking on it straight on like that. But what you must remember is that it's depicting angles. And they're not quite even all the way around. So basically, if you're looking at this, you're looking at a snail shell, basically. So that means then...
Fibonacci spiral?
Yeah. That means that on this line here, this isn't quite drawn exactly the way I want it to draw because it comes in a little bit straighter than that. And it comes in a little bit straighter than this. And it comes in a little bit straighter than this. Okay? And a magnet is placed here. And a magnet is placed here. And a magnet is placed here. Okay? So that means if this is north, south, because you saw the indicator go by the gate, north, south, that gives you 3 magnets on the top of this disc. Okay, and that means you're going to break this. That's what Howard was doing in those pictures. You're going to break this with 3 more. And what it's making up is a V-notch. See? All right?
Yeah, that's right.
So
I did see something very close to this on the internet, but this is exactly what Howarda Johnsona was doing. And these all stay the same. So if this side's a north, this one's a south, and this one's a north, and this one's a south, and this one's a north, and this one's a south. Okay, and it stays exactly the same all the way around. So that when you end up, here's a south, right? Here's a north, here's a south, here's a north, here's a south, here's a north. Okay, and it just keeps going this way.
So that circle is completely filled up with that? Is it
No, it's just...
We're just going to use 9 magnets, or
Yeah, you just used 9 to get to start with, but yes, Howard was going to go all the way around the disc.
Yeah.
All right, so I'm just showing you the simple little
Right.
thing. And so here, this one's going to be a south, and this one's going to be a north, and this one's going to be a south. And I don't want anybody to get confused, because this is what it is. So when you go around with the magnetic indicator, red, green, red, green, red, green, red, green, red, green, except for one thing here. These magnets are facing, when you look at the side of the disc, they look like this. Pay very close attention. You have a north over here, and then on the other one you'd have a south, see? But you're only going to go across one gate at a time. But look at the angle. The magnet is sitting on the disc this direction. What did I say about this? I said the blotch wall was in the center. So what are we going to do? So all we got to do is put, if I get rid of this, I don't want you to get confused with all these letters. If I put a horseshoe magnet, just normal, north and south, above this at the correct angle, this is going to rotate. It's not going to go very fast. It's not going to run your house, everybody, but it's going to tell you that Howarda Johnsona was building an over-unity motor. This is what he was going to do, but he was going to change the angle into a V-gate. It's a little more complex than what the people can do right now. See, as it spins. He was going to hold a stationary gate and movable gates and then a gate above it, and it was sort of going to be shaped like this. Disc, and it was going to come through a gate that was shaped like this. And that was going to make up the horseshoe.
And that last gate that you drew is essentially a horseshoe magnet.
Yes.
In that kind of configuration.
Yes.
Yeah.
When Howard is showing you these squares that the train's running through,
Right.
he has made up a gate that sucks the magnet in with one polarity on the outside. But if I could draw this three-dimensional, and I was an artist, which I'm not, you would see that these were all north-facing inside.
Right.
See? And that this was, that as you come into the tunnel, it's got a south-facing side.
Right.
Because of the way he's shaping the magnets when he's cutting them. You follow me? He's cutting them with his rock saw to fit together, and he's making sure that there's this material in between that may be a rubber magnet that allows the blotch wall to shift.
Right.
You follow me?
Yeah.
And then this will go from north to south or south to north depending on what is going through that gate. So, in reality, what I've shown you is something that, and we've seen this, Tony, on the internet. Somebody's got one very close to it,
Right.
but not Howard Johnson's. Howard Johnson's is already here.
Yeah.
And the man knew exactly what he wanted to do. He was up there in the years, and I'm sure he was sick towards the end, but Howard wanted this stuff released to the public. He wanted the public to know what he was doing and how his magnets were working. And I've kept this on a really simple level for everybody because I'm not going to sit here and feed you a bunch of math and get you into something when I can just tell you how to do it. And you can experiment with it. And not knowing these data points. So we're talking about a magnet that's maybe, 1 7/8 inches long, 3/8 inches thick, by, 3/4 inches wide, okay? That's all we're talking about. We're talking about a Briggs and Stratton magnet that everybody used in the SG group or any group that is familiar with my work. And this is the way it was laid out. It's laid out at a specific angle, using this spiral.
Yeah.
You see? And that makes up, when you're looking at this, I'll redraw this so they can see it one more time. But
Yeah.
see? Think of your 3 magnets like this. And your next 3 magnets like this. You gotta have good bearings on this thing. It looked like Howard's pretty good bearing system there. Looks like Howard was gonna go for high speed is what it looks like, all right?
Yeah.
So you're basically looking at that. I'll say this again to you. If this is a north, this is a north, this is a north. See? And you keep going around the disc.
Yep.
You see? South, north. See it?
Yep.
And you do this all the way around the disc.
Right.
All right? But when Howard's laid out, instead of using a normal store-bought horseshoe magnet, all right,
Right.
Howard's gate went like this.
Yeah.
See? And what is Howard doing? When it's sitting on this rotor plate, I'm blowing up a magnet. It's sitting on the plate, right?
Right.
Axle through here. Magnet looks like this, right? When you're looking at it, this is the north-facing pole, opposite south side, north, south, north, south, north, south, north, south, all the way around, alternating, right? What is running the engine is it's crossing the blotch wall.
Yeah.
It's nowhere near the magnetic fields.
Great.
So it's vacuum energy in a spiral form that's running. I'm going to show it to you one more time with the gate. The spiral that's going to run the engine is just like what I showed you here.
Beautiful. Great.
A lot of submarine transmissions. Howard was brilliant in the way he laid out this wheel. You can see here that each one of these magnetic structures underneath is asymmetrical. See it? See, it would be over the top here, it starts to narrow here, it gets narrower, 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 narrower. See, until it's almost, and then it does something completely different here, right? And what I noticed is that the gate has to be sort of constructed like this, and these magnets have to be cut to make up Howard's magnetic structures. See, a piece of neo here, neo, magnetic rubber. And it's these angles that you have to cut, you know, which Howard used the rock saw for.
Yeah, he had a diamond tip saw, yeah.
Yeah, you have to have a diamond tip saw to cut the ferrite blocks. And so I'm going to draw the gate structure.
Okay.
And Howard has, according to his drawings there, said that this has to be in a bearing. Right here, and he shows that. So I guess the bearing's going to go through here. And these magnetic structures here,
So the gate is on a bearing?
no, the wheel's on a bearing.
Oh, okay.
Yeah, he has it on a bearing, and I think he was working on his later one shows 2 bearing supports at each end, okay?
Right.
And the gate is the thing that's very important because it's got a slice of neo. The gate actually looks, you know, sort of like this. But this portion of the gate, right, this all becomes, say, a south, so that it attracts in this north over here.
Right.
And then this flips, because of the way he's got this arranged with, these are actually cut pieces, cut blocks of magnetic material. So see, if this is, this portion here would be sort of the center, but in between here he's got these rubber magnets, which I've showed you on the train car.
Right.
And these are all made up of pieces, and these are neo-tipped. And some of them are split, which means there could be 2 souths here. See, and this becomes a real strong north.
So where's the split?
Right here. So if you looked at this portion, the way he's tipped it is with 2 small pieces
Okay.
of neo. Now,
Right.
let me give you an example of the gate here that we're going to work with. And you can see it's a dual gate, see? And see how the poles are stronger here and here, and the thing moves by, and then it switches. I mean, we're talking about I have 3 dual gates to work with here on this motor, because they're not all the same. You see what I'm getting at?
Right.
So we look, you know, at Howard's gates. See, here's the gate face. See? South, south, south. So as the motor comes inward, right, as this motor's attracted, let me get this out of your way. If we're looking at the motors on this disc that Howard's building, right, as this, if we just put one magnet here like Howard's doing, and we say this is a north and this is south. This is a stationary magnet. Nothing has been changed on this magnet. Okay, but let's say it's coming into the gate. So the gate is something like this, and it's down below the motor. This, in other words, this end is going down below the motor, see, and the gate's coming back around below, like this. See? So it's like a U, almost.
Right.
Right. But some really, this magnet, even though that this is a north polarity or a south polarity on this side, right? It has to attract this magnet in. It has to, before any switch can occur, we have to have the magnetic fields, if it's like this on a plane, and we have this magnetic field, this is the first switch in, and this is the second switch out. That's what he's depicting there, and he's depicting the magnetic field this way.
So
So
what's the thing up on the top?
these
Above the waves, what's that up there?
up here,
Yeah.
oh, this is where the strongest part of the magnetic field is.
No, but my question is this, let me just point. What is this up here?
Oh, just space.
Okay.
We're not worried about it.
What is this line here then?
Okay, this is the gate. Let me go back to this again so you can see.
Okay, got it.
See what it is?
Yeah, okay, got it.
So what has to happen here is, even though this is a north side, right? A north pole in, underneath.
Right,
And this is a north underneath, right? Actually, this becomes a south with Howard's gate. But anyway, what has to happen here is this is going to repel. You follow me? So Howard's tricked the magnet into this type of field where it sucks it in, and then it's got a break point, a neutral point, and then it's got one hell of a push out.
yeah,
You follow me?
yeah,
So the face of this thing, the face of this gate, you can look at it this way, it's like a box, has to look to the magnet like it's south.
yeah,
Notice I said it has to look to the magnet, to this magnet like it's south, so it can pull it in.
right,
Because we don't want it to come here, get this far, and then repel and push back.
right.
See?
Yeah.
That wouldn't do very well, right? So inside here, in this box, see, this gets very complicated because Howard is like in 3 dimensions. See? And this is north now. So it's like a north tunnel.
Yeah,
So here's what has to happen with this little simple experiment. Remember, Howard Johnson was brilliant when it came to the two-particle spin theory. So if we're saying this is the gate, it has to be attracted like this, which means it's being sucked upward, see?
okay. Right,
And it has to spin, and that gate turns over, and the spin goes the other direction and
Right.
pushes it out.
right,
So remember what I said, you know, everybody thought, well, what is John doing this flux gate in the year that he did it, right?
84.
I was studying these spins, the right-hand spins, on the same pole. See, there's 2 sets of spins on the same pole. Because if I put an arrow here, up, right?
Oh, where's the arrow? Right,
You see, I get a spin, right? See it? Right here. Get over here where you can see it there. And get it right.
Down, boy. Got it.
See?
Yeah.
And if I turn the gate over, it's still the same north. I get the opposite spin.
Right.
Well, how can that be?
Yeah.
You've got one north pole, right?
Yeah.
Well, it's the gate. It's the vortex spin. It's his theory. Exactly, his two-particle spin theory on the same magnet. So you know what that means? When we look at all this, that means that Howarda Johnsona knew how to take this one signal magnet, right, and divide it in two.
Yeah.
So he knew that if he made this gate, right, that he knows that the spin's going to go one direction this way and the spin's going to go the other direction this way. But since these are all north poles facing each other around the gate, right, they do spin that way. One is going to spin this way and one is going to spin that way. And this proves it.
Yeah.
That he knew exactly what he was doing, because I can get the spin to go that way. And I can get the spin to go this way. And this is the same pole. So you don't see a south anywhere here.
Yeah.
And if I turn it over, it's still north. But when I draw it like this, at the gate, with all these magnets, this is inside this gate, right? And on the outside of this gate is going to be all south, and on the inside is going to be all north. What happens is when it gets to the center, it starts to spin this direction, and when it gets here, it goes the other direction. Well, that's what a motor does.
Yeah.
You know, you come in and you have this pole, right, that's north, and when this pole comes in on the motor and it's north, it's repelled out, right? You see what I'm saying?
Yeah.
But if I was to switch this, this would then be a south it'd be attracted in, right?
Yeah.
Because this south is attracted by this north. And it's still spinning. So when you build this Howarda Johnsona motor, which I know most people will probably try to attempt from this DVD, and you have to understand the way Howard thought about magnetic fields, and you must remember that Howard's magnetic fields are strange. He's cut these magnets, right, to interlink. So suppose this was a south, and this one's a north over here, and he put another south here, and he put another north here, but he bonded it, you follow me?
Yeah.
And then he tipped this with a piece of neo, right? This field is pushing outward up here in dots. See? Because it wants to push outward this way. And this one wants to push outward this way.
Yeah.
You see? So depending on where he's placing this gate, you know, and he's making this gate, the magnetic fields are going to look really,
Yeah.
you know, when you plot them out, see? And it's much too complex to go into for people that don't design magnets in this documentary series.
Yeah.
Unless, you know, they're going to try to design magnets, but Howard's done something
much more unique in that he's used a piece of magnetic rubber in between here. And then he's cut his block. And you can see that on the train. And then he's even cut it at a funny angle where it goes out like that. Now what's the magnetic field, right? Until you plot this out, I mean, this magnetic piece of rubber does not have the strength of these two magnets.
Right.
So it's right where he wants it to switch.
Yeah.
He wants it to switch at that point.
Where does he want it to switch?
This is neutral in here.
Right.
It's low magnetic field on both ends.
Right.
It all of a sudden comes into the gate at an angle, if you can look at it here. See? It's like looking at it like
Right.
instead of climbing the mountain straight up,
Yeah.
Howard's taking it at an angle.
Yeah.
A good indication of that, and we'll go back to this for a minute, is this is the cuts in the magnet. This is the wheel. That's kind of strange, isn't it? The twist motor, he called it.
Yeah. Yeah.
So if you're looking at this magnetic structure and you notice that he's got a green here and he's got a red here, and look what he's got right here. He doesn't say.
Where the X is, the cross.
Yeah, he says 13, which is magnetic rubber,
Right.
okay? See, rotor,
5 rotor.
yeah, 5 rotor, number 5 ferrite, right? So actually what we're looking at is something that's kind of like this, right? I'll get it as close as I could. And then there's this gap in between. And not quite so much of a gap on that angle, see? So when you look at this magnet, if this is the North Pole and you end up with it, I'm not going to draw the whole thing
Right.
because you can see it right here.
Yeah.
Right? It's a 17.5-inch wood wheel that he's playing with. So you know that this north, right? See, this south is shortened,
Yeah.
you see? And this is magnetic rubber, something like that in between.
Yeah.
Because when the magnet comes by, he wants the switch to occur.
Right.
So what he's done is it's brilliant. He's made magnetic switches. See?
Sort of like Radiss's boots.
Yes, exactly like Radis.
Right.
He's locking in a memory in this magnet.
Right.
By the way, he's cutting and fitting it together. It's almost like nature, like you're looking at a crystal, right?
Right.
And I can relate to it really good because I built plenty of crystals in my life in the oven.
Right.
And I know what the makeup of those crystals are, and some of them were magnetic crystals. But Howard can't go and buy a magnet that sort of the graining is, and I'll give you an example. If you had the magnet, and you know that the grains in that magnet are tightly packed, right?
Right.
And the more you pack those grains, and when they energize and they line up, right?
Right.
The higher the magnetic field's going to be.
Right.
But suppose you only have a few on this pole, and a lot on this pole.
Mm-hmm.
You see what I'm saying?
Yeah.
Then this field here is going to go like that out, and this field here is going to go like that in.
Yeah.
See? And when you look at this, if this is the north, this is the south, you can see the south area is far stronger.
Yeah.
But Howard says, let's cut this, put a piece of magnetic rubber in here, which is not, we don't know exactly the material yet that he used, right?
Right.
But we're working on that.
But there's plenty of that available out there.
Yeah, so you can just get it anywhere. It's
Right.
like tape rubber. So what Howard wants to have happen is, what if this conveniently stays all the same like this, but in this condition with the magnetic field out here, right?
Right.
See? Right? It's keeping it in this switched condition, right? But as this moves this way, this just like moves up. This just gets weaker, and
then
that
flips.
gets stronger.
Yeah.
See? He's making asymmetrical magnets, and you can see it right here, and you can see it. Let me show you one other block. See, look. He shows you the placement of the magnets, and then he shows you them put together.
So there's the placement of the magnets, right?
Right? This is where he wanted them.
And what's the tracing paper?
Tracing paper is where he wanted them.
Okay.
He traced the exact setup for
Right.
the gate that he's going to make here.
Right.
Notice you see, he indicates by these red and green marks, and the orange ones. This is a different material.
Right.
See, look here. It's cut into shape.
Yeah.
See?
Yeah.
And he's putting all these gates together to make one magnetic field.
Right.
That looks sort of like that.
Yeah.
There's one strange magnetic field.
And very asymmetric. Hugely asymmetric.
Yes.
John, I have a question.
Yeah, sure.
Thinking about this and looking at the gate down there and all of these magnets, all these angles, how could he replicate, or anybody replicate that for a commercial thing? I mean, every time you try to replicate
Well, you
it's
can't.
different.
You see, you can't, right, not one person's going to build one machine the same.
Okay.
But what you can do is, by making the magnetic material, let's just take the banana, right? By taking this banana magnet, right, and changing the material in here somewhere. In other words, changing the mix of the material. You're gonna have to mold this magnet so that it contains these materials in certain areas in this banana magnet. That's exactly what Howard was doing. Tony, that's why he wanted to take the rock saw.
Right.
He said he had to take his rock saw, and he
Right.
had to start cutting all this,
Right.
right? Because he couldn't have made this motor without doing that.
Right.
Because he couldn't buy the magnet that had different materials in each area that were different. You follow me?
Yeah.
There wasn't anybody that was going to make this.
So by building a mosaic, he could tailor it.
Yes, he knew he learned that a long time ago, that with his theory, right? Because he said Feynman was the closest
Right. He said.
to understanding all this. But Tom Beardena one time sent me a book that said there's so many differences in magnetic fields, and there's so many magnetic things, right? And each material is so different.
Right.
I don't think Howard was ever able to get the amount of money that he needed to go to a laboratory where they could mix the material for the magnet that he needed.
I think that was Cullerty's book on magnetic effects, and
Yes,
he said like there's 400 magnetic effects,
Yes.
and only like 200 of them are really known what goes on, and the other 200 no one really has a clue.
that's right.
And they've just actually reissued that book.
Now, if you look at this normal banana magnet, right, let's just say that's it, right?
Right.
You know the magnetic fields are going to go like this because you've seen it in science class,
Right.
all right?
Right.
But Howard's banana magnet doesn't do that. Howard's banana magnet, he's tipped, he's cut, he's added a piece of rubber, It's not the same. Forget about this.
Double tip.
Right?
Yeah.
Some of these banana magnets, he's got a piece of rubber right down the center that's bonded together to make the magnet.
Right.
Right? And then you put it in the machine, and this field lops way out like that and comes back like this. You see what I'm saying?
Yeah.
And so he's made an asymmetrical magnet.
Right.
Or in the nonlinear range, it's nonlinear.
Yeah.
It's not a linear magnet.
Yeah.
Because he wants this to do something.
And he knew in advance
Yes.
exactly what he wanted that magnet,
Right,
magnet to do.
right. He
wasn't just like stumbling into something.
Oh, no.
Yeah.
No, he was,
He had a plan and he was executing the plan.
I don't think folks really understand out there, or the people, just what Howarda Johnsona was all about. If you look at his work, and you study his work, you know that the man, he never talked. He was very secretive. You'd call him up on the phone, and I'd call him up on the phone, and I'd say, "It's John," and he'd go, "Oh, hi. How you doing, John?" And I'd say, "Howard, have you ever heard of blah, 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 blah?" And about a minute would go by, and Howard would answer on the phone. And I'd say, "Howard." And we had quite a few conversations. It took me a long time to get through to Howard, and Howard to get through to me. But I don't think people understood that he never was going to tell you anything about how he was doing this.
Well, you have to
You
remember.
weren't going to see it. In other words,
Yeah.
if he was working with anybody, the person would be untrainable. You couldn't train him,
Right.
Well,
Howard's background was in cryptography.
yes, very
And
secretive.
You have to remember that after World War II, he was offered the job of head of cryptography for the Navy, and he turned it down. So that's,
You have to be a very secretive man your entire life.
yeah.
And Howarda Johnsona was very secretive. He never gave away his secrets.
Yeah.
It's only now that we can begin by what Howard gave to you, right?
Right.
And said, "Here, you guys can have this." I mean, why would he take the folder out from underneath his bed and hand it to you if he didn't want you to have it?
Yeah. Exactly.
Well, the answer is right here. He wasn't going to tell anybody what these actual gates were going to do.
Yeah.
But the clue that he left was this. See these? He has made the gates underneath this magnet that he's cutting, so that this thing rotates just like this. And I bet it would have been about that fast.
Right. Right.
And so I just
Look,
congratulate Howarda Johnsona, and I'm just going to say that, that sorry that he never talked to anybody, and nobody ever really took an interest in Howarda Johnsona because he never talked about it.
Yeah.
He just did his magnetic experiments at night and measured it out. Tony, this was a very long study
Yeah.
on Howarda Johnsona. And why would you build? I mean, it's like looking at the pyramids. Do we really know how they're built? No.
Yeah.
Do we know what the mathematical points of this, of the pyramids are? Yes.
Or what they're for.
Yeah. What are they for?
Yeah.
But when you figure out what Howarda Johnsona was doing here, believe me, you
John
or I,
John
right,
Bedini. Yeah.
or I, if I build this, right?
Right.
If I build just this block, it's a pretty big block.
Yeah.
What do you think that magnetic field's going to look like?
Yeah.
I'm going to tell you. what I think it's going to look like. Because I got a pretty good hunch that this is one of the best switching gates if we just take this flat plane. And let's just say all these blocks are in there, right?
Right.
Well, how many spokes are in the wheel, right? This magnetic field's probably going to look okay. Why do we think that it's going to look like that? Because the waves indicated the poles, basically. So what Howard is actually building here is a fuelless motor that works just like an AC induction motor.
Wow.
He doesn't have any energy, he doesn't need any energy, because once he gets the magnetic fields to look like that, right?
Yeah.
The thing will rotate.
Yeah.
It has to rotate.
Yeah.
I mean, there are experiments you can do. You know, there's experiments that I've done in my life where I can tell you if you take a disc like this and you and say this is the magnet, and you take this magnet apart and you break this into all poles like this, right? If I put in here, right,
Yeah.
a shaft, and I bring a rod out and I face a pole magnet this way, right?
Uh-huh.
If I break a certain spot here, right, everybody knows if you start here with the magnet, it's going to go seek the neutral.
Right.
It's going to seek the delta zero. I call it delta zero. Okay? But if the magnetic field actually went like this, this thing would go, just rotate.
Right. Just cog around.
Just cog around. And that's, Howard shows it here. And he shows it right here with this unique magnetic structure, because he says the twist motor using spin units.
Yeah.
It's right there in black and white, everybody.
Yeah.
He gave you the folder because he wanted somebody to keep up his work. There's a very simple method that an experimenter can do to find out. He can take a magnet, right?
Right.
And he can add a needle end to one magnet. That's going to shift the blotch wall
Right.
so that this field's going to be big and this one's going to be a small field.
Right.
Yes, they can find out. They can do simple experiments with Gauss meters to find this out. They can data point every one of these points. They can even add a piece of material to the side of the magnet. And then the field is going to do, it might go.
And they can even refer to the plots that we've shown them in this DVD.
Absolutely.
It's a really good reference for them.
That's right.
Yeah.
Howard Johnson helped me when I had nothing. A $500 check came out of nowhere. And in the end, as you know, when the SG started to go and everything here, Tony,
Right.
and the book started to work, I wrote Howard Johnson a check and sent it to him. So I just want everybody to know that Howard Johnson might have been a very quiet man, but he was a very brilliant man.
Yeah.
And I was glad to help you out with this.
Well, thanks very much, John. Appreciate it.